Hello, it's Ryan here from RLF Vacuum Cleaners in Lakenheath, and in today's video we're going to be talking about heating elements. Electric heating elements are remarkably simple. They're just giant resistors. What they basically are is just basically got your two electrical connections at the top. You've got these two white bits here, that's your insulation, and you've got your outer, and basically inside is basically some wire wrapped around on a coil. It's usually made out of nichromia wire. The insulation is normally, majority of the time, is made out of magnesium oxide, and they usually come in fancy shapes like this. You get the spiral one, and then you get one like this, biggie one like this, where it's actually wrapped around itself. Heat elements are remarkably simple. There's a giant resistor. They basically use a lot of electricity. These ones use a lot of electricity because they're used for heat and water. They basically use a very large amount of electricity, and they generate this into heat to heat things up. Now, I'm going to bring in a heat element in the middle to show you what they are inside, what they're like inside. This here is actually a three-phase heating element. Basically, you connect one phase up and then the rest to neutral. But this one's actually exploded. I don't know how the camera is going to pick this up, but you can see it's completely split open. You got the wire hanging out. You got the wire hanging out here. So if we bring that in, you can see you've got this coil of nichromia wire, and that nichromia wire is insulated. You can see it's split open, and you've got this magnesium oxide insulating it from the outside. Fault finding on heating elements is remarkably simple. There's only ever two things that ever go wrong with them. They either go open circuit, so they just stop working, like this one has. You can see the wire's blown off, it's gone open circuit, this one's actually exploded. Or they go short circuit, which means they draw a lot of current. Usually when they go short circuit, you take out breakers. Majority of the time heat elements, when they fail, they just split like this, water gets in, and they trip out your RCD, because this metal outer case is actually earth, and water gets in there. Magnesium oxide is very hygroscopic, it absorbs water. So basically you have water touching the live wire in here. This is all live uninsulated wire. It touches that out, shorts to earth. It can be tested very simply. You can do an IR test on them, but usually when they fail, you just use a normal ohm meter. So what we'll do is we will stick that wire on there. Wire on there. Bring in the ohm meter, and you can see we're getting 35 ohms on that one. Getting 35 ohms on that one. Now this one, failed one's actually been taken out of circuit, so what we'll do is it should hopefully open the circuit. Oh no, we're actually getting 76 ohms on that one, so there's actually something connecting somewhere, even now actually open circuit. You can see the wires hanging out. So it's obviously conducting to the outer metal. So then if we connect that up, we're actually getting 64 ohms between the heating element and earth. Now 64 ohms is, just a bit of ohms law in my head. Heat elements work on resistance, so you do resistance and voltage, and that tells you what sort of current will flow. So we're looking at about 750 watts, we're looking at about 3 amps. So we're looking at a current of about 3 amps going to earth in this state. This is actually taken out of a hot water, hot beverage and steam generating machine. As you can see, it's a 3-phase element. This is a 4.5 kilowatt element. These are pretty beefy, but they'd be pretty beefy in the application they're used for. And again, they're having issues with it tripping their RCD. You can see why. It's completely split open. So yeah, that's basic introduction to heat elements. They're basically just a resistive current flows through, usually at a low resistance. Usually around this one's 35 ohms, so it's about 1500 watt per element. 3 of them up to 4.5 kilowatt. That 4.5 kilowatt generates a lot of heat. These big ones like this, if you run these out of water, they won't last more than about a minute before the wire inside actually melts. When they're submerged in water, this particular one, I'm talking of a temperature of about 135, 140 degrees. That's what they run at, and they will heat up quite a lot of water to 130, 140 degrees rather quickly. Obviously you get smaller elements like this. This is a 3 kilowatt element. Looking at about 18 ohms for that one. And then we've got this one, which is actually one that looks quite long. This one's only 1500 watt. The long one here is only 1500 watt, but this is used in the machine. We have 2 of them, so you have 3 kilowatts. Heat elements are used all over your house. And in industrial applications, they're used in immersion heaters, kettles, oven, tumble dryers, washing machines, anything that needs really any heating really. If you want to heat a liquid up, or fan heaters, they're all heat elements. Electric heaters, they're all heat elements. Storage heaters, you know, there's thousands of applications for them, and they're basically just power in, live and neutral. Because these are heat elements, you can run them on pretty much anything, any sort of voltage. But obviously the operating voltage they run on is best. Fault finder is nice and easy. Just use an ohm meter, and obviously multimeter, ohm meter doesn't give you any ideas. Usually they fail. Usually go open circuit. Usually. Occasionally you might get one with short circuit or split open and be an earth leakage fault, but yeah, that is the basics of heating elements. Any questions? Let me know.